Next, I'd like to invite our next speaker, Dr. Henning Loeser. He's the head of Audi production at Audi in Germany. Please join me welcoming Dr. Loeser.
Thank you, Andy. Well, now I have the big task after this magnificent talk of Peter and Melanie to get you into what we do. Who am I? What are we doing? And these are this is the topic of the next few slides. So I want to give you a short introduction of our Audi production sites. A lot of you know Audi for its beautiful cars. I'm from the like I used to say, the dark side of the power. I'm from the production side, dark side of the force. We have always, and this is a quote from our founder, August Horch, we've always tried, since the founding of Horch Company and later on the Audi Company, to build great cars. And that cannot be done without the production. Here are some numbers. I'll skip over those. They are the numbers from 2018, 2019. It wasn't released yet, so you can look at those later. The important thing is this one. We have quite a few production sites across the world. Our main production sites being in Germany, but we also manufacture globally, as you can see. And to give you a little feeling, this are the numbers for our Ingolstadt plant, where I'm located. It covers an area of almost 2.7 or a little more than 2.7 square kilometers. We have 40,000 people working there, and we have the capacity to build around 500,000 cars a year, which boils down to a little bit more than 2,000 cars a day. Same thing for our Neckarsulm plant. It's a little smaller, less people working there, still an area of 1.2 square kilometers. And you see the models we can build in Neckarsulm. So these are plants that are set up for high volume car production. And what we, from the production side, always strive for is stability. And we have been building cars for years, for decades, like a lot of other companies have been doing. And there was always the feeling, there is something out in this world out there that is probably useful for us in production, but we don't know. There are these cool new technologies. What did Peter say? They are glimmery and shiny like in the candy store, but are they really nice and sweet candies we want to swallow or we want to have, or are they not useful for us? So what we are striving for is, or wanting is something that I didn't find a better English word, so I just used the German. It's a culture of ideas, Ideenkultur. This is what we want. We want to have prototypes. We want to be creative. We want to be fast. We want to move the future. We want to shape the future. And you can only do that by being innovative, by trying out new things. And on the other side, production is the left side here on the slides. Well, actually, for you, it's the right side. So it's a culture that's very structural. You want to drive for series production. Don't change a thing. It's organized, it's stable, it's producing cars in numbers. If you're working in that field, the only thing you're looking for is, in my shift, we have to produce 300 cars. If I only produce 299, I'll have to report to my boss, and he's going to ask me why I did not produce that car. Ask him about failing. No, not an option. Technology has to be stable. And now come the people like me who have these crazy ideas, and they say, hey, listen, we've got this really cool part here, and we want to try this out in your production side. And they say, okay, and what's that going to help me? And you tell them, well, you know, this is really cool, and if it does work, there's a lot of business value in there. They'll ask us, well, will it work? Well, it worked in our lab once, and they'll say, no way I'm ever going to let you with that piece of technology into my plant. The other way around, the world is not optimal. We have a lot of challenges in production. And the question is, how can we solve these challenges we have in production by just going at it from a different angle, getting other experts into there, getting people into there, getting new technologies into there, and then solving actual production problems. And so this mindset was the mindset we had in 2012 when we founded the Audi Production Lab, making the Audi Production Lab to be the zipper between these two worlds. Because people on the idea cultural side, as I said, they try something out in their labs, coming from the outside, coming from universities. If they cry out, "Eureka, it's working," they mean, "I've tried this now for 1,000 times, and finally, at last, it somehow worked." In production, if you say it's working, what they think of, you do this 1,000 times, it works 1,000 times. And so just from the culture, from the entire speaking with one another, these two worlds don't interconnect well. And that's what we are for in the Audi Production Lab. I have the honor of running the Audi Production Lab now since 2016. What I want to get you into now are some of the things we've been doing over the last years. A big thing that Peter and Melanie also stressed on is that the key focus of generating business value is to network expertise and not organizations. So within the Audi Production Lab, we always try to get the experts we have either internally or externally to get them working on a project to actually make the project work, to make the work succeed. And the other big part of that is if you work in the lab and you want to try out something new, you have to be allowed to break some rules. For sure, not risking cybersecurity issues we heard about, but you have to do something different from what you've been doing in the past in order to actually innovate, to actually do something new. And for that, you need a confined area, a space where you can try out something new, where you can challenge things that the institution has known for ages. Yeah, I know this can't be done because 10 years ago I tried this once and it didn't work. Well, yes, that was 10 years ago. This traditional knowledge, which is kept within organizations for an incredibly long time, to overcome that, you need confined areas where you can then actually try it out in order to figure out, is there a business value in what you want to do or not? So, what are we doing in the Audi Production Lab? I'll start with this proof of concept. Spot welding. Spot welding is the probably most well-known joining technology in car production ever. We've been doing this for, it seems like millennia. Not quite that long, but since ever, spot welding. So what have we achieved so far? If we look at spot welding, it's the main joining technology in our body shops. You have around 5,000 spots per car. The equipment availability is up at 99.9%, and if you have a good maintenance crew, you can add some nines at the end of that. So this is a great technology. Is there a business case in doing a predictive something with that? And the answer is yes, there is. Why? Because no technology is 100%. You'll get some nines if you want to add more nines towards behind the comma. You'll have to spend a lot of money. So the question is, can we get better? What do we do today for quality inspection? We do random sampling. We take parts out. We do ultrasonic tests and figure out, okay, are the spots good? Are they not good? If they're not good, we go back into the process and adjust the parameters of the process. But that's a manual process. And the idea we had was, well, can't we cut down on this ultrasonic inspection? It's the industry standard. That's what everybody does. But can't this be done better? Save those people, make them free to do other tasks in quality inspection, but not do all the time these ultrasonic inspections. And so that's where we started, and we started looking out of the box. We talked to the colleagues from Intel, asking them, listen, how do you drive your operations based upon the data you have? And then they helped us with this POC in order to tap into our data. And the first thing we found out, well, when we started this project, we thought the biggest challenge would be to devise the AI algorithm that gives us the insight. But that was wrong. The biggest problem we had was actually getting the standardized access to the machine data. Yes, we did send the data in the past already for post-mortem inspections. If there were some errors coming up, we could look into the data and see when did it change. But we did not have the data labeled correctly. The biggest problem we were facing was coupling data generation with the production process. Up to now, we only knew, okay, this is the production data of the spot weld with the number 1,441, together with a timestamp of the robot when it sent that data point. But to which actual part does this spot belong? If you're thinking about the very first stages of a car where you just weld a couple of parts together, they don't have a name. So the first problem we were facing was actually giving the parts names, giving them numbers so that we could identify this is spot 1,441 coupled to this exact piece, or these two pieces joined together. That was the first thing we needed to learn, because a timestamp is not a good identifier in order to figure that out. With a timestamp, you can limit it to, well, it's one of those 10 probably. That's not good enough. You want to know the exact same piece. The next problem is, are you really sure that the timestamp you have in your data point is a valid timestamp? Looking through our spec sheets, we discovered, well, yes, when setting up the robots, we required all the equipment to synchronize with a time server. But are you sure that actually every robot and every spot welding gun does synchronize with the time server? Are you really sure? Well, no, because it wasn't necessary. Up to now, that wasn't necessary. So it was actually making those data points valuable, enriching it, or not even enriching it, but, well, yeah, for the name, enriching it, but making those data points valuable for us in order to be able to conduct the analytics. So the next thing then, after we had done that, was visualizing process data. That was easy. Training an algorithm. Here comes the next point. If you do this on a technology that is very well known with only very few errors, how many false or how many negative values do you have in order to train your model? Well, very few. So we trained the model, and it came out that with this model, we had the ability to predict whether a data point was good with an accuracy of more than 90%, and also to predict that a spot weld point is bad with more than 90%. This is excellent. And now you go into the OT world and you talk to the colleagues and tell them, hey, listen, with more than 90%, I can tell you this data point is good. And they say, okay, what's with the other 10%? So there is a mind change that has to take place, because the answer to that is, well, I don't know what's with the other 10%, but it's always better than the statistic sampling you're doing right now. Now you only need to do a statistic sampling with those 10%, and that will save you money. So this is something that has to change in our culture and in our way of thinking. So what we've been doing is setting up this. We have these curves. We have the errors that can happen in spot welding, and we set up a system where we get the data out of the tooling, out of the machines, into a database. We do the visualization. We train the algorithm. We have the trained algorithm. And now, You have a trained algorithm, but you don't want to have this algorithm running in the cloud because that's way too late. If something happens, it happens on the shop floor. You have around a second between one spot weld to the next spot weld. So you want to have this algorithm deployed right down to the shop floor where the latency is from the networking is good enough so that you can actually interfere with the process. Here comes the next point. If you talk to OT, to automation people, and tell them, okay, listen, I need to deploy this algorithm to all of the spot welding robots and the spot welding guns, they tell, yeah, sure, give me a thumb drive, we'll put it on. That's valid if you do this while setting up a factory, while remodeling a factory. But if you have an AI algorithm that you train on very few data points, every time you discover a new error, that error is really valuable and it will lead to a retraining of the algorithm. So all of a sudden the requirement is, hey, listen, I want to distribute these algorithms on a bi-weekly basis. And people will tell you, what? No way I'm going to run with a thumb drive to every machine twice a week and deploy it because I just don't have enough time during the running operation to do that. So we need to think of new ways of deploying these algorithms. And so that was the next, or that is actually now the next thing we're working on, is trying to figure out how do we set up a system, an open system that is able for us to let us deploy algorithms into our shop that then do in-stream analytics on the edge. Why is that on the edge so important? For spot welding, it probably is not quite as bad because you do a spot weld, you have some sparks coming out which will lead, or which we want to control. Why? Not because the spot weld is bad after the sparks coming out, but because the sparks coming out of the spot weld will have little metal pieces that can stick somewhere into the car that make a very sharp surface. And so if somebody else is handling something there later on, you have to protect your workers because otherwise they can cut themselves on the sparks that lay down or that are sticking to your car. So, but another case where we already have the algorithm is in the riveting process. In the riveting process, you punch the rivet through the metal sheets, and at the end, the counterpart of the rivet that makes the rivet forced to go apart, if that thing breaks, the next rivet you're trying to set into your car and every other one after that, after this thing broke, will not be okay. So we found out an algorithm that lets us detect when these things are breaking. And now how do we deploy this? Because we don't only want to deploy this for a single rivet manufacturer, we want to deploy these to all of our riveting guns over all of our factories. Again, the same challenge, you have an algorithm, you want to deploy it, how do you do that? And now comes even the next thing. Once you have these algorithms deployed, how do you train your maintenance people to work with that? You see, it's a lot of evangelizing. So I'll use the evangelizing example I use in our factory. Think of a street light. Think of a street light operated by an AI algorithm. And this AI algorithm gets updated, and for whatever reason, at this one intersection, this update mechanism did not work. From the central steering, you don't notice that this didn't work. Only thing you do notice is the streetlight doesn't work anymore. So somebody calls in and says, hey, at this junction, this streetlight is not working anymore, and you send out an electrician. The electrician goes there, opens up the cabinet, and says, well, okay, electricity is there. If I switch this manually, the light's working. I have no clue what's happening here. So you have to train your maintenance, your normal maintenance people in order to work with these new capabilities. That's a big transformation process because they are the ones who know the equipment, they know the tools, they know the electricity part, and now they have to understand in much more detail the algorithmic part that's going to find its way into the cabinets that they are usually working on. So this is a challenge we are facing for training our maintenance people for this proof of concept. This proof of concept was very successful. We showed that it can work. What we're doing now is we're taking this out of the production lab, we're taking this out of the proof of concept stage, and we are giving this into our VW Group digital production platform so that this very process can then be scaled out to the entire factories of the VW Group. And this is the way things should work. You had the idea, you had the business value, I can save on quality inspections, we have the algorithm that's working, and now you scale it out in order to harvest on the business value by doing this process. Now, I'm almost at the end. I'll just make a little advertisement for myself. I'll be giving a little bit more insight on the platform and the hardware consolidation project we'll also be doing, and the chips to cloud forum panel tomorrow. Thank you for your attention.